Welcome back to linear algebra. Let's jump into Anki to begin with today. All right, two flashcards. What we got? If a homogeneous linear system has n unknowns, and if the reduced row echelon form of its augmented matrix has r non-zero rows, what can you say about the number of free variables of the system? The number of variables is going to be n unknowns, non-zero rows. Isn't it going to be n minus r? N minus r. Yeah. Come on, dude. Wonky with the lag. If A is an invertible matrix and n is a positive integer, what does the symbol A to the negative n denote? N is positive, so it denotes that it's the inverse of A times the inverse of A times the inverse of A n times. All right. There we are. So now I'm going to go ahead and grade the problem I did yesterday. I think it was just the proof. Maybe it was more. Go from there. All right, so we got the proof correct. Really, I'm still just going for validity with my proofs. Considering I've written like less than a dozen proofs in my entire life, I don't really care about the elegance or the rigor or like the structure. What I care about is that I'm not focused on proof writing right now. I'm focused on learning linear algebra. So if I can reason through linear algebra first principles and objects and definitions, then that's what I'm going for, and that's all I'm seeking. So ChatGPT said it was correct, and he was actually extremely impressed that I've never taken a proof writing course before, and then I've self-taught myself all this linear algebra, so it's kind of cool. And I got the true false right. So yeah, from here I'm gonna go do some more practice problems. I don't have that ton of time because I was talking with ChatGPT a while about the proof and stuff, but yeah, I'll be back in a bit. All right, so I actually just happened to get a random review question that I'm doing, and it's another proof. So this time we're proving that the resulting matrix of K times A, the transpose of that resulting matrix is equal to the transpose of A times K. And basically, this is almost self-explanatory, but basically, K are scalars, A are matrices, to the power of T is transpose. So, K means we're multiplying each entry of A by K, by the definition of scalar multiplication. And then the transpose of that is just going to be taking the rows and turning them into columns, and then columns into rows, switching the rows and columns. And so that's going to be the same thing as this, because multiplying the entries by K doesn't change anything about the underlying structure of the matrix A. So you can either do it before you take the transpose or after the transpose. Either way, the rows are going to become the columns are going to become the rows, and each entry is going to be multiplied by K. So that's it for now. I will talk to you again tomorrow. See ya.